Hello, and welcome to another video. Today's topic is going to be related to abstract data types again, specifically polymorphism and interfaces. If you haven't already watched part 1 of this video called What are Abstract Data Types, I would recommend doing so first because you'll be introduced to some of the examples from that video. Last time we talked about creating classes to create user-defined data types. These classes allowed for one object to have multiple types, and this was known as polymorphism. So let's talk a little bit more about that first. The word polymorphism, broken down into its constituent Greek root words, literally means many forms, in the same way that an object in a program can have many forms or types. Polymorphism is a really useful tool because it allows our code to be more flexible, which a lot of the time actually turns out to be very convenient. So how can we achieve polymorphism? Let's look at two ways. First is inheritance, which we briefly introduced in part 1 of this video. The example we saw together was an employee class inheriting from the person class, therefore allowing an object of type employee to also be of type person. This also meant that the employee class had access to the contents of the person class. In this case, the person class is what we'd refer to as the superclass, and the employee class is the subclass. In terms of implementation with Java, this is seen with the extends keyword, so you'll see something like public class employee extends person. Inheritance is incredibly useful. It allows for code reusability, which means we can reuse elements from an existing class with very little effort. One limitation, however, is that a subclass can only inherit from one superclass at a time in Java. So, what if that wasn't enough? Well, this is where our second method of achieving polymorphism comes in: interfaces. Before we can understand how interfaces work, we should be clear on exactly what they are. In the previous video, we established that a class contains a set of instance methods and instance variables. These respectively are our behaviors and characteristics. It may come as an initial surprise that an interface is just behaviors or just methods. In fact, it's actually a little bit less than that. It's only a collection of method signatures without any implementation at all. We can think of an interface like a blueprint for a class. A blueprint will show you what a structure will look like, but the structure has not even been built yet. Similarly, when we create an interface, we haven't done any implementation yet. Let's, for example, have a shape interface. This interface contains the method signatures for a getPerimeter method and getArea method. But there are many shapes that involve different calculations for their respective perimeters and areas. Here's where our implementation classes come in. The circle class and the rectangle class will both implement the shape interface. Now, an object of type circle or type rectangle is also of type shape, so we've already achieved some level of polymorphism. Even though they have the same methods, they will look quite different. For example, the getArea method for the circle class will do something like pi r squared, and the getArea method for the rectangle will carry out something like length times width. Classes that implement an interface can also have their own independent elements too. For example, the circle class can have a variable for radius and its own getDiameter method, which multiplies the radius by 2. The rectangle class does not need a radius variable or a getDiameter method. Interfaces are effective at achieving polymorphism because they aren't limited like superclasses and subclasses. Multiple classes can implement the same interface as we've just seen with the circle and rectangle implementing the shape interface. But one class can also implement multiple interfaces, and interfaces can be used in combination with inheritance. For example, we can make a subclass for rectangle called square. In this case, an object of type square is also of type rectangle and of type shape. I want to briefly draw your attention to why this level of polymorphism might be useful. Now that I've implemented my rectangle, circle, and square classes, I could create, for example, a list of squares because all the objects in that list are of type square. But I can now also create a list containing rectangles, circles, and squares because all of these objects are of the similar type shape. Interfaces are also useful because they help us to facilitate multiple inheritance, which cannot actually be done with just inheritance alone. They also help us to achieve a level of security because they hide implementation details from the user, and this is exactly why they're abstract. In part 1 of this video, we saw that abstraction refers to hiding the complexity of a system underneath a higher level idea. This is the same kind of thinking that we saw with abstract data types, and this applies to interfaces as well. By creating an interface and various implementations for it, we have set up the behaviors for our defined abstract data type. In this case, you saw that with the circle, rectangle, and shape example. My hope for you by this point is that you're beginning to understand that using inheritance and interfaces will affect the behaviors of abstract data types, and that you also have a basic understanding of the fact that objects can have multiple types. I also hope that in general, the whole concept of abstraction is becoming slightly more clear. As always, thank you so much for watching, and feel free to leave your thoughts and questions in the comments below.